All right, if you're a network administrator, you definitely know this feeling. It's one of the most frustrating scenarios out there, and I'm willing to bet you faced it before. You look at your dashboards and everything's green. Packets are flowing, life should be good. But the help desk phones are ringing off the hook. The tickets are piling up, users are complaining, and suddenly all eyes are on you. So this is where we have to go way beyond a simple connectivity check and start a real, proper investigation.
So what we've got here is a classic case of the network is slow. You know the one. The user can't really explain it, but they feel it. They just know their critical applications are dragging. And when you look, the Session Smart Router, or SSR, it seems to be chugging along just fine. But we know better than to just look at the surface, right?
This is the point where you could start frantically clicking around, just guessing. But we're not going to do that. Instead of just randomly checking settings, the platform actually gives us the tools to follow a structured, logical method to get to the root cause. It's really about turning that frustrating art of troubleshooting into a repeatable science.
And here's our roadmap for that science. We're going to follow this really clear 6-step method. This is what's going to take us from that vague user complaint all the way to a real solution.
Think of this framework as our guide through the madness. It takes that super vague complaint, it's slow, and turns it into a series of actual concrete questions we can answer, one by one. It just gives us a logical path to follow from problem to proof and make sure we don't skip anything important.
Okay, let's dive in. First things first. Before we can figure out what's going wrong, we have to know what's supposed to be happening. So we're going to trace the intended data path from the user all the way to the application.
Now, to start, we've got to get our heads around a key concept in SSR, and that's the tenant. Just think of it like a label. It's a simple tag for any source of traffic. So whether it's your voice network, a specific customer, maybe the finance department, tenancy just lets us group that traffic together so we can apply specific rules to it. It's really the first step to organizing the chaos.
So our whole investigation kicks off with one simple question. Who's making the request? Where is this traffic actually coming from? And we find that answer by mapping the user's source IP to a specific tenant that's already configured in the SSR.
And here's exactly how we do it. You hop into the command line, run a command like show tenant members, and boom, you get this simple lookup table. So let's say a user on the 10.192 network is the one having a problem. We can look right here and instantly see they belong to the voice.cus tenant. Just like that, we've identified our subject.
Okay, this next part is super important. We need to understand how the SSR decides which service a chunk of traffic belongs to. It is a very specific order of operations. Think of it this way. A rule that matches the exact port and protocol, like, say, UDP port 53 for DNS, that rule will always win over a more general rule that only matches an IP address. Getting this hierarchy is key because it makes sure your traffic gets classified correctly.
All right, so once we know the service, the next question is, what path is it taking? And that brings us to Secure Vector Routing, or SVR. Honestly, the best way to think about SVR is like a really smart GPS for your data packets. It's not just looking for any old road to the destination. No, it's constantly measuring the quality of all the available roads and picking the absolute best one based on things like latency, packet loss, and jitter.
So how do we actually see what this smart GPS had decided? Well, it's easy. A simple show load balancer command tells you everything. You can see right here it knows the path over WAN 0.0 is down. So what does it do? The SSR intelligently routes everything over the LTE.0 path instead. Yeah, the latency might be a little higher, but hey, a working path is always better than a broken one.
Okay, so let's recap. We figured out the intended path for our users' traffic. The next logical step? We got to test it. We need to verify if this path is actually healthy and, performing the way it's supposed to.
And really, this is the million-dollar question, isn't it? The SSR has picked a path that it thinks is up, but as we all know, up does not always mean good. So we need a way to actually prove the health of the entire data path, from one end to the other.
And this is where a tool like Service Ping becomes your best friend. Now, this is not your standard everyday ping. What makes it so special is that it uses the exact same service, the same tenant, and the same routing logic as real user traffic. So what does that mean? It means we're sending test packets down the very same path the application is using. That gives us a true, real-world measure of its health.
But sometimes a ping just doesn't cut it. We need to see the whole journey. And that's where we level up to selective packet capture. This thing is seriously powerful. It lets you trace a session from the very second it enters the network, and it automatically triggers captures on every single SSR it hops across. The result? You get this incredible, unparalleled end-to-end visibility.
Okay, but what if the path checks out? The service ping comes back clean, the trace looks great, but that user, they are still complaining. This is that frustrating moment when we need to broaden our investigation and start looking at the overall health of the system itself.
You know, sometimes the problem has nothing to do with the SSR's logic. It's the underlying transport, the pipe itself. A classic example of this is an old physical T1 circuit. The link might be telling you it's up, but underneath, it could be just riddled with physical layer errors that are absolutely killing performance.
And this right here is how we find the smoking gun. You just look at the T1 performance counters. Are those physical errors going up? If you see numbers like these for bit errors or out-of-frame errors just ticking up and up, you've found it. You've got a physical layer problem with the circuit, and it's time to get your provider on the phone.
Now there's a number that, as an SSR admin, should always make your ears perk up. And that number is 85%.
So, why 85%? What's the big deal? Well, that's the alarm threshold for high CPU utilization, and it's also the threshold for other critical resource pools, like the flow table. When you see an alarm at 85%, that is a crystal-clear warning sign that your system is under strain. It's telling you it might start struggling with new sessions or big traffic bursts.
Another thing to think about when it comes to performance is how the router actually processes new sessions. So in older versions, before 6.1, this was all handled by a single thread, which, as you can imagine, could become a real bottleneck. But starting in version 6.1, things changed. Session processing became multi-threaded. This lets the SSR use multiple CPU cores and handle way higher connection rates. It's a really key architectural improvement, especially for scaling up.
And finally, let's not forget about the simple stuff, configuration errors. You see an alarm like duplicate asset ID, and that can cause all sorts of weird connectivity problems. And it usually happens for one of three really common reasons. Someone cloned a VM and didn't reinitialize it, the same quick start file was used on more than one router, or, yep, somebody just made a typo. It's just a good reminder to always check the basics first.
Okay, so let's pull all of this together. What we've just walked through, it's not just a random list of commands to memorize. It's a complete troubleshooting toolkit, and it's all built on a really clear philosophy.
And that core philosophy is simple, but it's super powerful. First, you follow a method. You replace guesswork with a clear structure. Second, you verify the path using tools that were built for the job, like service ping. Third, you get full visibility with things like selective packet capture to see the whole story. And finally, you check your system health and rule out any basic conflicts. When you put all that together, path validation, system health, and a config sanity check, you can solve even the most wicked problems, and do it efficiently.
You know, when a platform builds these kinds of deep diagnostics right into its core, it fundamentally changes how you approach problems. It just does. Which kind of leaves us with one final thought. With a toolkit like this, is troubleshooting no longer that frustrating art of guessing, but maybe, just maybe, it's a science of discovery?